In this video, we're going to go through some logarithmic expressions, popcorn style. Things that should be very, very quick and easy for us to do as long as we know how logarithms work and our properties of logarithms. Starting with this first one right here. In this example, the base of the logarithm is the same as the base of the expression inside. And if those guys are the same, there's that theorem on inverses which says it's just going to be the power of this guy on the inside. Now, another way of looking at this, you can apply properties of logarithms and take this power inside and rewrite that out front to say 58 times log base 7 of 7. And if you do that, we recognize that this guy right here, log base 7 of 7, is equal to 1. So you have 58 times 1, which is still 58. So no matter how you slice it, the answer here is just going to be 58. So hopefully you remember the theorem on inverses, and if these guys are the same, the answer is just your power. Over here, log base 767 of 1 is going to be 0. One of the things that we've seen so far is that log base a of 1 is going to be 0. Okay? Doesn't matter what the base is for that logarithm, as long as it's a legitimate base, log base a of 1 is going to be 0, no matter how big or small this is. Because you have to think, what's the power that's going to give you 1? Remember, anything raised to the 0 power gives you 1. And the answer to the log is the power, so it's 0. Here, when I have just log, we remember that log, the common log, is log base 10. So we're trying to find the power of 10 that gives me 1,000. When it comes to an expression like this in the common log, if this guy's a 1, you really just have to count the number of zeros. So I see 3 zeros, so my answer is 3. Which means that 10 to the third equals 1,000. And again, the logarithm is just looking for what is the power. All right, so the power there is 3. As a little side note here, if I did this, if I said, for example, what's log of 1 over 1,000? Well, log of 1 over 1,000 would be negative 3. 3 because of the 1,000, but negative because it's in the denominator. Fun with powers. Over here, log base 39 of 39. Well, that's kind of the same thing that I was doing over here, right? If the base of the log is the same as the expression inside, that's just going to be 1. So one of the key points that we had for logarithmic functions is that log base a of a is 1. Go ahead and box that so some of you guys don't freak out watching the video. All right, coming on down here, natural log of e to the 8,129. Well, we remember that natural log means log base e. So this is log base e of e to the 8,129. And again, since these guys are the same, that means that your answer is just going to be that power, 8,129. Done and done. And while we're talking about natural log, let's talk about this guy down here. So we can rewrite this as the natural log of e, so it's e to the 5th in the denominator, which means it's e to the negative 5th, like that. And since we know that the base of the natural log is e, and the base inside here is e, then my answer is just going to be that power, which is negative 5. And that's it. Over here, well, things are a little bit trickier, right? But notice that if I didn't have this radical, if I just had this, right, you could say that the power of 3 that gives you 27 is 3. So you could answer that logarithm. So let's do that. What's the power of 3 that gives you 27? That's 3 But since you have an index here, that becomes the denominator of your power, so that becomes 3 over 11. Another way of looking at this is that this is log base 3. If I just rewrite this expression, you know that 27 is 3 to the third. The index of 11 becomes the denominator of the power, like that. And here, the base of the log is now the same as the base of the expression inside, which, as we've seen already this video, is going to leave you with just the power. And finally here, we have 57 raised to a power that's a logarithm. Fortunately for us, the base of this exponential expression is the same as the base of the logarithm. And when those guys are the same, you just get the expression inside the logarithm. So the answer here is the square root of 15. And again, this goes back to that theorem on inverses that says if you have a raised to log base a of x, you just get x. So these are some fun little popcorn questions that we can ask, fun stuff to put on a quiz, sprinkle in there on the test. So make sure that you practice with these, make sure that you know your properties of logarithms, and everything's going to be fine.